Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces. Today we're talking about something you've probably experienced if you've ever used an AI chatbot.
Oh, yeah. You ask it for something really specific, like a list of ingredients in a particular format for an app you're building, and it starts its answer with something like, "Of course, I'd be happy to help you with that. Here is the list you requested."
Exactly. And that friendly little intro completely breaks the computer program that was expecting just the data. The program sees words, not the structured code it needs, and the whole thing fails. It's a small annoyance for us, but in the world of automated AI agents, it's a huge problem.
It really is. These AI agents are being designed to do complex tasks like booking flights or querying databases. They need to communicate with other computer systems using a very precise, structured language like JSON. When the AI messes up the format, the entire pipeline breaks.
And the only solution is to try again. This doubles the computing cost, it adds a ton of time, and in the worst case, it can cause hidden errors that mess things up way down the line. This is the problem tackled by a new paper from Purdue University called ATLAS-RTC, Closing the Loop on LLM Agent Output with Token-Level Runtime Control.
That's a mouthful, but the core idea is brilliant. Right now, we mostly try to fix this problem in one of two ways. The first is prompt engineering, which is basically just trying to ask the AI in the perfect way to get the right output. It's like crossing your fingers and hoping for the best.
The other way is called post hoc validation. This means you let the AI generate its entire response and then you check it. If it's wrong, you throw it away and try again. It's like proofreading a book after it's already been printed. You can spot the errors, but it's too late to fix them cheaply.
So this paper introduces a totally new approach, ATLAS-RTC. Instead of hoping for the best or checking at the end, ATLAS-RTC acts like a live editor sitting over the AI's shoulder, watching it generate its response one piece at a time.
And when we say one piece at a time, we really mean it. It operates at the token level. A token is basically a word or a part of a word. ATLAS-RTC is a runtime controller, which means it's intervening in real time as the text is being created to make sure the AI doesn't go off the rails.
So how does it do that? It uses what the paper calls a closed-loop control pipeline. At every single step for every single token, it observes what the AI is about to generate, predicts if that token is likely to lead to an error, and then applies a control to steer it back in the right direction.
My favorite part is how it applies that control. It's not just a simple yes or no. It has what they call a graduated ladder of interventions. It's like having different levels of nudging the AI.
Right. At the lowest level, if the AI is just drifting slightly, the system gives it a gentle nudge. This is called logit biasing. It's like whispering to the AI, hey, you probably want to use a quotation mark here, not the word sure.
The AI is a bit more confused. ATLAS-RTC can climb the ladder. It might use temperature modulation to make the AI less creative and more focused, or token masking to completely forbid it from choosing certain tokens that would break the structure.
But the coolest, most powerful tool is at the very top of the ladder, mid-step rollback and correction. This is amazing. If the controller sees that the last 2 or 3 tokens were a complete mistake, it can literally hit undo, undo, undo.
It's like a tiny time machine for the AI's output. It rolls back the generation by a few tokens, corrects the course, and tells the AI, okay, let's try again from this point. This prevents a small mistake from turning into a catastrophic failure, all without having to restart the entire generation.
And there's another clever piece to this. The system is stage aware. It understands the difference between when the AI is building the rigid structure of the output, like the curly braces and commas in JSON, and when it's filling in the values, like a movie title or a city name.
So it's a strict supervisor when it needs to be, enforcing the rules of the format, but it backs off and lets the AI be creative when it's supposed to be writing free-form text. This avoids the problem of other systems that are so rigid, they actually make the AI's output worse.
Okay, so the theory is great. A real-time, token-level supervisor with a ladder of interventions and a time machine. But did it actually work?
It worked incredibly well. The researchers tested it on a few tests. In one test, they asked the AI for structured output, like a JSON file with a name, age, and city. Without the controller, the AI got it right on the first try only 56.7% of the time. With ATLAS-RTC, that jumped to 76.7%.
That's a 20-point jump, which is huge, but the results on AI agents using tools are even dramatic. On a task where the AI had to format a query for a search engine, the normal, uncontrolled AI failed every single time, a 0% success rate.
0. But with ATLAS-RTC watching over it, the success rate for that same task went from 0% to over 90%. It basically took a completely broken capability and made it reliable. Overall, it improved the first attempt success of agent tool calls from around 28% to 58%.
That's incredible. It's the difference between a tool that's useless in the real world and one that you could actually start to depend on. Now, the researchers are also very honest about what ATLAS-RTC can't do.
Right. It's a structural supervisor, not a fact checker. It ensures the output is perfectly formed, but it can't tell you if the information inside that structure is correct. It makes sure the JSON is valid, but it can't tell you if the capital of a country is right.
They even found a case where its performance was worse. In a send email task, the base AI often failed because it would forget to include a required summary field. ATLAS-RTC would enforce the correct structure, but because it couldn't invent the missing summary, the output would still be flagged as a failure. It exposed a different kind of error.
Which is still valuable information, but the big takeaway here is a shift in thinking. Instead of treating AI generation as an uncontrollable process that we have to clean up afterwards, this paper shows that we can actively govern and control the generation process itself, token by token.
It's a move from generate then check to guide as you go. By closing the loop and intervening in real time, ATLAS-RTC makes AI agents more reliable, more efficient, and less prone to the kind of silly formatting errors that can bring entire systems to a halt. It's a crucial step towards building AI we can truly trust with complex tasks.
And on that note, that's all the time we have for today. Thanks for tuning in to Daily Papers. We'll be back next time with another deep dive into the world of research.